Hi everyone, welcome to this data annotation course. I'm your instructor, and today we're diving into the first part of the material. Hope you're ready, let's get started.
In this chapter, we'll focus on speech data annotation. First, we'll start with an introduction, then move on to an overview. After that, we'll explore typical open-source speech data annotation tools, the overall process of voice data labeling, diversified voice data labeling projects. Finally, we'll have a chapter summary, as well as homework and exercises. With the progress of deep learning algorithms, intelligent voice processing technology is experiencing revolutionary changes. Algorithms, computing power, and data are the three main drivers for its rapid development. Voice data resources are the foundation of this technology. Only with large-scale, accurate, and high-quality voice datasets can intelligent voice processing technology progress better. Although it performs well in some businesses currently, there are still scenarios where the effect isn't ideal, like heavy accents, dialects, noisy environments, multiple people talking simultaneously, and far-field voice. This requires both improving deep learning algorithms and designing, acquiring, and producing more voice data resources in diverse scenarios. In the Internet era, high-quality voice datasets are crucial for the booming voice industry. In recent years, with the development of artificial intelligence, there have been breakthroughs in intelligent speech processing. Especially with the continuous penetration of deep learning, new algorithms like end-to-end technology keep emerging. Their application in real-world business systems has significantly enhanced the performance of intelligent voice processing technology. Large-scale applications such as robot telephone customer service systems, smartphone assistants, and smart speakers have shown good performance in limited scenarios, and there will be more application scenarios in the future. Also, here is a figure showing the popular research directions in intelligent speech processing technology. When it comes to cognitive speech signals, physically, sound is mechanical vibration transmitted as sound waves. So, sound characteristics depend on the properties of sound waves. In daily applications, common speech and sound characteristics include timbre, which helps distinguish different sounds, like a person's voice and a violin's sound, and is an important object in voice recognition research. Pitch is the high or low of the sound, determined by the sound wave frequency, with male voices usually lower and female voices sharper. Sound intensity is the strength of the sound, determined by the vibration amplitude of the sound wave, similar to the signal amplitude in the voice signal waveform. Sound length is determined by the pronunciation time. Digitized voice signals convert the continuous analog voice signals from people into discrete digital signals for easier computer processing. This process involves several concepts. The sampling rate is the number of samples per second on the continuous voice analog signal, measured in Hz. Quantization digits convert the amplitude value of the sampled speech signal into a value within a certain range, and the number of quantization bits refers to the number of binary bits. The number of sound channels, or channels, is the number of input or output signal channels like mono, binaural, or stereo. The speech coding format compresses the sampled and quantized values in a certain format, such as PCM, WAV, or MP3, to reduce audio data for easier storage and transmission.